theorem of calculus, particle motion, and average value. Some of this will be review, but then we're going to push it on. 3 things to always keep in mind. Number 1, and I guess I want a highlighter. If you integrate velocity, you get position, right? So if you integrate the velocity from A to B, then you get P of B minus P of A. That ought to make sense because the antiderivative of velocity is position. So you would evaluate your position at B minus evaluate your position at A. Now, let's look at number 2. The integral from A to B of V of t dt is the net distance the particle travels on the interval from A to B. Now look here. The integral of the absolute value of V of t dt is your total distance. Now we're going to come back and talk about the difference between net and total distance with an integral. Now, let's look back at net distance. The net distance the particle travels on the interval from A to B. If V of t is positive on the whole interval, meaning if my velocity was always positive, then that means I never change direction. So if I never change direction, if my velocity is always positive, then net distance is the same as total distance. All right? If I change direction, the net distance and total distance are not going to be the same. Yes. Yes, it would be the same thing. Do you know where to find absolute value on your calculator? Math, and then I think you have to arrow left and right. Yeah, arrow right to num. And it's the first one. It says ABS. We will use that today. Abs. We will use that today. So look back at number 3. If you integrate the absolute value of the velocity, you're going to get total distance that the particle travels on the interval from A to B, whether or not the velocity is positive. To be safe, always do this integral when asked to find total distance. Here's what I want. Any time that you are being asked to find total distance, I want you to use absolute value. And you say, but Stennett, I know that it's always above the x-axis. Great. But let's not take chances, okay? Now what I want to show you over here in this empty space is we're going to look at a couple graphs to help you distinguish graphically net distance and total distance. So we're going to just draw 2 little graphs over here, make them ish, okay, like so. That, let's do it. Let me do it like this. I'm like, I know it's bad. Well, thanks. It's not the worst thing in the world. Okay. So if I have an integral, an interval, let's see here. Let's go A to B. And I find this area. Oh, this is V of t. I'm sorry? A function. It's a velocity function. If I integrate this from A to B, am I going to get net distance or total distance? Both. I'm going to get both. I'm going to get both because if I do the integral, I will get net distance. But because my whole graph was above the x-axis between A and B, the net distance will be the same as the total distance. Okay? And then if I have, let's take the same function. Change direction. They won't go to negative x values, go to negative y values. Negative x values are over here. If my a and b are here to here, and I find this, is that net distance or total distance? If I just integrate from a to b, that's going to be net distance. Because, well, some of that's going to offset, right? Some of it's positive, some of it's negative. So if you add those together, some of that's going to cancel out. Now, I don't know if that's exactly 0, but that's your net distance. Now, here's the deal. If I did this, that red graph that I just drew would look like this. Which means I would be finding this, which is total distance. Why does absolute value flip it up? That's right. All those y values can never be negative anymore. Those y values are positive. So when you do an absolute value, it's just going to make sure everything is above the x-axis, not below. You with me there? Now, so we got 5 minutes because of RTI. When this is velocity, oh boy, let me erase. I was thinking about this last night. Now let's let this be in seconds, and let's let the velocity be in feet per second. Okay? If I integrate this velocity from a to b, and I don't care what the function is, that's not an issue right now. What units will I have? Is it feet or is it feet per second per second?
You're going backwards.
If I integrate velocity, I get position. So it's just going to be feet. Now I want to show you something. If we go back to a Riemann sum, let's just try to make this pretty easy. If I go back to a Riemann sum, and I'm just going to be really pitiful, and I'm just going to break this into just 3 subvariables. And we're going to do a this. You're going to tell me what a this is. That's a left-hand Riemann sum. Is that left-hand Riemann sum going to be an overestimate or an underestimate? Under, good. Now, when you do a Riemann sum, what you are doing is you are adding those areas together. How do you find the area of any rectangle? Base times height, right. Length times width, base times height. Now, the base is your x value, right? Your height is your y value. So we are multiplying x times y, correct? The x value times the y value. Now, the x value is measured in seconds times the y value, which is being measured in feet per second. You multiply those, you get feet. Yeah. I was thinking about that last night and thought, I think maybe I need to talk to them about that. If this had been acceleration,
Would it be?
because this would be feet per second squared. So doesn't it make sense that your units would be feet per second? And when you integrate acceleration, you get velocity, which is measured in feet per second. But what I just want you to understand the relationship between these rectangles and the units. X times y. This times this. Okay? We'll pick up after lunch. So we're on number 1. The velocity of a particle that is moving along the x-axis is given by the function v of t equals 3t squared minus 6, or plus 6. This is a non-calculator active question. If the position of the particle at t equal 4 is 72, what is the position when t equal 2? Well, Why do I have to integrate? Yeah, because the integral or antiderivative of velocity is position. So if we integrate v of t, now we're going to integrate that from where to where? Why 2 and 4? I don't know the position at 2, but I do know the position at 4. So what we've got here is the integral from 2 to 4 of 3t squared plus 6. I put lotion on my hands and now it feels funny against the board. Plus 6 dt. T cubed plus 6t. Evaluated from 2 to 4. I didn't square. This is the lower limit here. That one goes up there. Okay. Oh, mercy. I don't know. Now, I want to make a comment right here. Notice that we are, yeah, I've got the stir back on. We're trying to find out what the position is at 2, right? Now, I know a couple things. I know all of this to be true that I've done so far. But I also know that this has to equal, pretend that I did not know what the function was, and all that I knew was this. What would the answer to that be? That would be p of 4 minus p of 2. Now keep in mind, I know what p of 4 is. I want to find out what p of 2 is. P of 4 is 72. So 72 minus p of 2 is going to equal whatever this right here is. Just, I'm gonna work through this the way that Sparks does, so that you can follow his notes. Okay? Yeah.
To work in the way that like people did 4 and subtract half from 2.
Yeah, and that's what we're gonna do. Yeah, that's what we're gonna do. If I evaluate this thing at 4, 64 plus 24, I think so, minus, evaluated at 2, 8 plus 12. So we've got 88.
It would be, you're subtracting minus 20.
Did I do something wrong?
No, I did. Yeah.
Let's. And this gives me what, 68 equals 72 minus p of 2. I promise I'm not ignoring you, what you're asking. I'm not ignoring you. So this gives me what, negative 4. I heard what you're asking, and I'm trying to figure out how to answer it, to be honest with you.
Like, why is the answer not 68? So isn't that how you define it? Like, you evaluate it. Wait, so what is 68 represent?
I don't have an answer for you off the top of my head. I'm going to have to think about that. Because I understand what you're asking me, and I don't know how to answer it. So what I'm going to ask for is some grace. Give me time to think, and I'll give you an answer when I think of it. Okay? But right now, off the top of my head, I don't know. What I think what Mason is saying is P of 4. Why this said P of 4 is 72, so why is this 88 not 72? That's what you're asking me, right? And then P of 2 then, it looks like that ought to be 20, but it's not. I don't think so.
Isn't that like what's the on the left side that?
When we do this, what we are finding, keep in mind the velocity, let's see, we don't have any units. If we integrate velocity, what we're getting is total distance traveled, or net distance. I should say net distance traveled, right? So when I do this, this particle would have traveled a net distance of 68 units, correct? That's what that means. That is what this means, is that from time 2 to time 4, that particle would have traveled a net distance of 68 units.
So it starts at 4 and ends at 72.
This, no. What was the position at time 2? If the position at time 4 was 72, what was the position at time 2? Now, the position at time 2 ends up being 4. So at time 2, it said that this thing was moving along the x-axis, right? So at time 2, this object would have been 4 units away from the origin. At time 4, that object was 72 units away from the origin. So if you'll keep in mind that this whole mess here represents net area, net distance, right? So net distance traveled. These over here are positions at a particular moment in time. So they're really kind of different. What is the total distance the particle travels on the interval from 0 to 7? Now, if you are trying to find total distance, 3t squared minus 6t? No, 3t squared minus 6. Now, you're going to need to do this one on your calculator. No. Yeah, there's an integral button. Now, where's the rest of my calculator? Math. Absolute math. Dummy. Math. Integral. From where we're going 0 to 7. T squared. That's a plus, isn't it? Plus 6. Is it plus or minus? It's plus.
Wait, second. I got this.
You will.
Okay.
Now, the question is, Why do you get the same if you integrate without the absolute value? Because if you graph, this one I got an answer for. Because that's a plus. That's a plus. That's my bad. I wrote the dang thing down wrong. That's a plus. If you graph that, it's always positive. The function itself is always above the x-axis. So your net distance and your total distance will be the same thing. So if you integrate 0 to 7 of 3t squared plus 6 dt, you're going to get the same thing, only because this function is always above the x-axis.
Wait,
Yeah.
what does that 385 mean? Like the number?
That would be the total distance traveled from time 0 to time 7. Page 2. This is a calculator active question. The velocity of a particle that's moving along the x-axis is given by that velocity function. Okay. If the position of the particle at t equal 1.5 is 2.551, what is the position when t equal 3.5? Yes, I know it's the same kind of question as before. Now, this is a calculator active question. Huh? There's a what? There indeed, there's an E. If I integrate from 1.5 to 3.5, v of t dt, the position of the particle at t equal 1.5, I'm going to plug in all of this into my calculator and I'm going to get some number that I'm going to put right there. I'll add 2.551 to it and I'll find out what P of 3.5 is. Or 15.919 something.
You have to
Now, before you keep your answer on your screen, the 15.919 whatever, and add 2.551 to that.
18.
18 point what? This is P of 3.5. 18.47 what? 0. Do you have questions? Hold on, yeah. Let's move on, please. Look at part B. Part B says, what is the total distance the object travels on the interval 1 to 5? If we're finding total distance, what do we do? So it's absolute value of that function. Run that on your calculator, see what you get. This is what Sparks says. See if you get the same thing.
That one?
Next, the graph of the velocity measured at, I don't even know what just happened there. Question? The graph of the velocity measured in feet per second of a particle moving along the x-axis is pictured below. The position, P of t, of the particle at t equal 8 is 12. Use the graph of the velocity to answer the questions that follow. What is the position of the particle at t equal 3? 3 to 8. Well, I'm just gonna tell you, if he's beating it up this much on the notes, I wouldn't be surprised if there was one on the quiz. Let's take a look at that. Now, we know a few things about this. We know that this is going to be P of 8 minus P of 3. But look at what we also know. We know that if we integrate a function whose graph we know, then we're finding the area under that curve of that graph. 3 to 8. So you got to find the area bounded here and here. Yes, sir. So, is this point right here, is that 4, 5, or is that 5, 5? Is that 4, 5?
Where?
That point right there. 4, 5? I'm going to do rectangle, triangle, triangle. That's a 1 by 5, so the area of this thing's 5. That's a 2 by 5, and then you take half of it, right? And that's a 2 by 2, 4, take half of it, 2, but it's negative because it's below the x-axis. So what's that area? 8. Now that's net. I'm told that P of 8 is 12. So what is P of 3?
4.
P of 3 is 4. Now, do we have any units here? P of 4. Snap. P of 3 is 4. Yeah. So the position at 4 seconds, the position. Do I? The position at 3 seconds is 4 feet. No. Part B, what is the acceleration when t is 5? Ah, the derivative of velocity is acceleration. How do I find the acceleration when t is 5?
Yeah, the slope of that side.
It's the slope of the tangent line, good. So what did we say that was, 4, 5? What is that?
Negative 5 halves.
5 over negative 2, 5 halves? Negative 5 halves. So we have a of 5. Yeah, acceleration at 5. 5 minus 0 over 4 minus 6, is that right? Negative 5 halves. Negative 5 halves what? Feet per second, good. Good. C, what is the net distance of the particle travels from t equals 0 to t equals 10? So I'm going to integrate from 0 to 10 v of t dt. Do I need absolute value? No. Well, what in the world am I going to do because I don't have a function? I mean, I don't have an equation. The area, yep. So I'm going to find all that sucker. I'll turn this off while I'm thinking. So this is 10. This one,
Wasn't that one 2?
half of 4 by 2. So that's 4, but it's negative because you're below the x-axis. So what's that, 16? 16 what? 16 feet. Now, do you understand why this makes sense? Because this is feet per second, and the time is in seconds. And we're finding area, so we multiply the base times the height if we're doing rectangles. So those cancel and you're left with feet. What is the total distance the particle travels from 0 to 10? You shouldn't have much work to do here.
You just, would you find it for instead of subtracting it?
Yep. Wendy said, wouldn't you just add the 4 instead of subtracting the 4? Yep, because that would flip this up here, wouldn't it? So it's going to be 20 plus 4 instead of 20 minus 4.
Wait, that would be 16, right?
Did I do it wrong? 20 plus 4 instead of 20 minus 4. Did I do something wrong? Okay, now we're changing up a little bit. We're going to a table. Oh, mercy. The table above shows values of the velocity in meters per second of a particle moving along the x-axis at selected times t in seconds. Okay. What does the value of 0 to 8... What is the value of the integral from 0 to 18 of v of t dt represent? What's that represent? Total? Net? Net distance traveled from in the first 18 seconds. But what do we know about net distance and total distance on this one? They're the same thing because the y values are always positive. So this is the net distance. In this case, also the total distance. What I would say, this integral is the net distance because by definition that is net distance, right? Is the net distance the particle travels during the first 18 seconds. Fully understanding that in this case, net distance and total distance are the same thing. You okay? Look at part B. Use a left Riemann sum of 6 subintervals of equal length and estimate the value of the integral from 0 to 18 of v of t dt. Left Riemann sum, 6 subintervals of equal length. 1, 2, 3, 4, 5, 6. Our first subinterval is going to go from t equals what to what? T equals 0 to 3. Are all of our subintervals the same width? Yay. So I can pull that out, right? Times the heights. Then I'd have to do each one individually. Base times height plus base times height. But since the base is the same on all of them, I'm going to pull that out. Remember, we're doing a left Riemann sum. What's the height of the first rectangle? 2.3 plus the height of the second rectangle plus 1 plus, when do I stop? Why? Because I'm doing a left-hand Riemann sum, right? Take just a minute and run that. You got 33, and it's distance traveled, 33 meters.
Question.
Yeah.
If it's the value of area, is it meters squared?
Using a right-hand Riemann sum of 6 subintervals of equal length, estimate the value. Oh, I never said what the last one was. Did y'all get, what'd you get here on this one? 33 feet. Can you do a right-hand Riemann sum
Yeah.
of 6 subintervals? So let's just start it. It would be 0 to 18 of v of t dt equals 3 times. Let's just put in the first couple. 2.7 would be the first height. 2.0. And what would be the last height?
2.1.
2.1. Now Sparks says here, he says, was this question E? Was it question C? He says 32.4. He says 32.4 meters. I'm going to leave it to you to do D and E because those are both Riemann sums. I don't think you'll have trouble with those. I do want you to do them. Please finish these notes. Let's go down to F. Yes, sir. I promise you'll have a calculator on anything that you need one for. I promise. You have a problem like this, of course you'll have a calculator. Let's go down here real quick to F. Find the average acceleration of the particle from t equal 3 to t equal 9. Now I want you to think about average acceleration. How would I find average acceleration?
Wasn't it like v of t?
So v of 9 minus v of 3 over 9 minus 3. Okay, so you get, if you run that, you should get about negative 0.233 meters per second per second. Now, I'm just going to say this, and you can get it off the notes later. It says for what values of t in the table is this average acceleration approximately equal to v prime of t? Since we did, look here, since we did the average acceleration and we used 9 and 3, you got an idea of what v prime of what that would approximate? 6. Why 6?
That's like the second line.
That's right, because 3 and 9 would give you the secant line around t equals 6. So that's why this would be a decent approximation of v prime of 6. Okay? Now, the last problem in here is an AP problem. I want you to work through that one. And anything you have trouble with, I want you to, let's address it the next time I see you. All right? We good? So those of you who are listening, finish the notes. I will have everything posted. And since this was kind of in a hurry, anything we need to tidy up, we'll tidy up Friday.
The homework